Amazon Web Services is the world's most comprehensive and broadly adopted cloud platform. It offers more than 200 fully featured services from data centers globally and is also one of the leading cloud service providers in the cloud infrastructure market. Amazon Web Services offers a variety of cloud-based products including compute, storage, databases, network security, and many more. So in today's session, we're going to talk about AWS Networking Fundamentals. We will talk in depth about VPC or the Virtual Private Cloud and a few other important networking services such as Direct Connect, Elastic Load Balancing, and Route 53. But before we start our session, I would like to address the agenda for today's topic. Firstly, we will understand what exactly is VPC and then see how does it work. Next, we will see some of the use cases of VPC or where can it be used. Moving on, we'll see an overview of other AWS networking services such as Direct Connect, Elastic Load Balancing, and Route 53. Then we'll conclude the session with the demo part. Now moving on to our first topic, what is Amazon VPC? Amazon Virtual Private Cloud is a service that lets you launch AWS resources in a logically isolated virtual network that you define, which means you will have a part of AWS Cloud that can be used only by your AWS resources and can be accessed only by you or the people you permit to access. Now, these people could be your business partners, your employees, or anyone you want. You will have complete control over your virtual networking environment, which would include selecting your own IP addresses range, creating of subnets, and configuration of route tables and network gateway. I will explain all this term in some time. Now, Amazon VPC allows you to create multiple layers of security, including security groups and network access control list, which will help you control access to your Amazon EC2 instances in each subnet. You can use IPv4 and IPv6 for most resources in your virtual private cloud, which will help you ensure secure and easy access to resources and applications. Now that you have some idea about what exactly is AWS VPC, let us move on to our next topic and see how does it work. But before we get into the working part, I would like to explain the terms which I mentioned before. So if you're wondering what are subnets, these are logical subdivision of a larger network. You can launch your AWS resources into a specified subnet. And when I say AWS resources, I mean your EC2 instances and so on. There are two types of subnet, the public and the private. You use a public subnet for resources that must be connected to the internet. And with a private subnet, the resources won't be connected to the internet. Now another interesting point is IP addresses of all the subnet in a network will start with the same prefix. Next we have is a route table. Now a route table contains a set of rules called route that are used to determine where the traffic in a VPC is directed. You can explicitly associate a subnet with a particular route table, otherwise the subnet is implicitly associated with the main route table. Each route in a route table specifies the range of IP addresses where you want your traffic to go, which is the destination, and the gateway, which is the network interface or connection through which to send the traffic, which is the target. Now, as I've mentioned about public subnets and private subnet, let us see the difference between them. So in a public subnet, resources are exposed to the internet using the internet gateway. They make use of both public and private IPs and are mainly used for external facing applications like web servers where you want your information to be visible to the users. Whereas in a public subnet, resources are not exposed to the outer world and it uses only the public IPs. They are mainly used for backend applications like database and application servers. Now that you have some idea about subnet and route table, let us move on to the working of VPC and understand it. Now if your account was created after 4th of December 2013, your account comes with a default VPC that has a default subnet in each availability zone. We will see this in the demo part. Now your default VPC includes an internet gateway and has the benefits of advanced feature provided by EC2 VPC and is ready for you to use. Now if you launch your instance in a default VPC and do not specify a subnet where to launch your instance, the instance is automatically launched in your default subnet, which is a public subnet. You can also create your own VPC and configure it as you want. This is known as a non-default VPC. Now the subnets that you create in your non-default VPC and any additional subnet that you create in your default VPC are called as non-default subnets. Now you can see we have something called an internet gateway. Now an internet gateway is a gateway that allows your instances to connect to the internet. You can do this through Amazon EC2 Network Edge. Each instances that you launch in your default subnet has a private IPv4 address and a public IPv4 address as you can see here. By default, each instance that you launch in a non-default subnet has a private IPv4 address but not a public IPv4 address unless you specifically assign it. These instances can only communicate with each other but cannot access the internet. But you can enable internet access for these instances by attaching the internet gateway to its VPC and associating an elastic IP address with the instance. Now, how can you connect your VPC to other VPC or to your on-premises network? So for this, you can create a VPC pairing connection between the two VPCs that enables you to route traffic between them privately. Now, instances in either VPC can communicate with each other as if they were in the same network. You can also create a transit gateway and use it as an interconnection between your VPC and your on-premises network. The transit gateway acts as a regional virtual router for traffic flowing between its attachment, which could include VPC, VPN connection, AWS Direct Connect gateways, and transit gateway peering connections. Now I hope you have some idea about the working of VPC. Let us move on to our next topic and see some of the use cases of VPC. With Amazon VPC, you can host a simple web application such as a blog or a simple website with additional layer of privacy and security. You can help securing the website by creating security group rule, which will allow the web servers to respond to inbound requests from the internet while simultaneously prohibiting the web servers from initiating outbound connection to the internet. Now what this means is you can control your data traffic in and out of your VPC. You can create a VPC that supports this use case by selecting VPC with a single public subnet only from the Amazon VPC console wizard. With VPC, you can also host multi-tier web application and strictly enforce access and security restriction between your web servers, application servers, and databases. You can launch web servers in a publicly accessible subnet while running your application servers and databases in a private subnet. This will ensure that your application servers and databases cannot be directly accessed from the internet. To create a VPC that supports this use case, you can select VPC with public and private subnet in the Amazon VPC console wizard. With Amazon VPC, you can also backup and recover your data after a disaster. By using Amazon VPC for disaster recovery, you will receive all the benefits of a disaster recovery site at a fraction of the cost. You can periodically backup critical data from your data center to a small number of Amazon EC2 instances with Amazon EBS volume. Or you can also import your virtual machine images to Amazon EC2. To ensure business continuity, Amazon VPC allows you to quickly launch replacement compute capacity in AWS. These were some of the use cases of using VPC. Now let us move on to our next topic and see an overview of the other networking concepts in AWS. First, let us talk about Elastic Load Balancer. Elastic Load Balancing automatically distributes your incoming traffic across multiple targets. The targets could be EC2 instances, containers, and IP address in one or more availability zones. It will monitor the health of your registered target and route traffic only to the healthy target. It scales your load balancer as your incoming traffic changes over time. You can add and remove compute resources from your load balancer as your need changes. It will not disturb the overall flow of requests to your application. Now, Elastic Load Balancing offers 4 types of load balancer. First is the classic load balancer, which provides basic load balancing across multiple Amazon EC2 instances, and it operates both at request level and the connection level. A classic load balancer is intended for applications that were built within the EC2 classic network. Second, we have Application Load Balancer. It is best suited for load balancing of HTTP and HTTPS traffics and provides advanced request routing, which is helpful in modern application architecture, including microservices and containers. Third, we have Network Load Balancer, which is best suitable for load balancing of TCP, UDP, TLS, where extreme performance is required. A network load balancer routes traffic to targets within Amazon VPC and is capable of handling millions of requests per second while managing ultra-low latencies. Fourth, we have the Gateway Load Balancer. It is used to deploy, scale, and run third-party virtual networking appliances. Gateway Load Balancer is transparent to the source and destination of traffic, which makes it well suitable for working with third-party appliances for security, network analytics, and other use cases. This was about Elastic Load Balancer. Now let us take a look at AWS Direct Connect. AWS Direct Connect is a cloud service solution that makes it easier for you to establish a dedicated network connection from your on-premises to AWS cloud. Using AWS Direct Connect, You can establish a private connection between AWS Cloud and your data centers or your office. You can increase the bandwidth throughput and provide a more consistent network experience than internet-based connections. AWS Direct Connect is also compatible with all the AWS services and is available in the speed starting from 50 Mbps and can be scaled up to 100 GB per second. It helps you build hybrid environment which allows you to use the benefits of AWS and continue to utilize your existing infrastructure. Now let us move on to our next service, which is Route 53. Amazon Route 53 is a highly available and scalable cloud domain name system or DNS web service. It is designed to give developers and businesses a reliable and cost-effective way to route end users to internet applications by translating names into numerical IP addresses. This can be used for computers to connect to each other. Now Route 53 performs three main functions. First one is it registers your domain name. Every website needs a name, be it edureka.co or anything like facebook.com. So Route 53 lets you register a name for a website or web application known as a domain name. The second function is it routes internet traffic to the resources for your domain. So when a user opens a web browser and enters your domain name or the subdomain name in the address bar, Route 53 helps connect the browser with your website or web application. The third function is it checks the health of your resources. Route 53 sends automated requests over the internet to a resource, such as a web server, to verify if it is reachable, available, and functional. You can also choose to receive notification when a resource becomes unavailable and choose to route internet traffic away from the unhealthy resources. Now these are some of the networking services in AWS. Now let us move on to a demo part where I will teach you how you can create a VPC, your subnet, your route table, and an internet gateway. So for our demo, I've logged into my AWS console. If you do not have an AWS account yet and want to practice AWS services, I would highly recommend you to create an AWS free tier account where you can access more than 75 AWS services for free for a year. So a point to remember is your VPC will be set in this region. In my case, it is Ohio. You can see there are so many regions available here. Your VPC can be set in your selected location. Now let us start a demo. We'll search for VPC. You can just search over here, VPC. Here it is. Now when you click on your VPC, you can see there is a default VPC as I mentioned before. It will also have a default subnet inside it. So now let us create our own VPC. So we'll click on create VPC. So it will ask us to name our VPC. Let me name it demo VPC. Now when you create a VPC, you must specify a range of IPv4 address for the VPC in the CIDR block, which stands for classless inter-domain routing. We will go for the primary CIDR block, which is 10.0.0.0/16. Now mention 16 over here, which means 16 bits is reserved for my VPC network. Now we'll go with the default. I do not want any IPv6 CIDR block. Next we have tenancy. Now here you can see we have two options. One is default, the other one is dedicated. So what dedicated means is you can run your instances in your VPC on a single tenant or a dedicated hardware. So we'll just stick to default here and create a VPC. Then you'll get a message saying you have successfully created your VPC. This is your VPC ID and this is your VPC name. Now let us create a subnet. Now as I've told you in the theory session, a default subnet is created. And you see we have three default subnets over here. When I just scroll here, you see the three default subnets are created in three different availability zones. So each availability zone has one subnet in it. So now let us create a new subnet. We have to select a VPC from here. This is a VPC. Next we'll come down and we'll name a subnet. Let us name it demo subnet. Now we have to select a availability zone. We have three availability zones in Ohio. We'll just select one of these. Now we also have to mention our IPv4 CIDR block for our subnet. So we'll just set it to 24. So when I type 24 over here, it means 24-bit is reserved for my VPC network. Now the starting of the IP address of the subnet should be the same as the starting address of your VPC. Now after this, let us create a subnet. This might take a few seconds and you can see you have successfully created your subnet. This is your subnet ID and this is your subnet name. Next we'll create our internet gateway. We'll get back to route table in a few minutes. Now as you can see, there is a default internet gateway, but we will go ahead and create our own internet gateway. So here it will ask us to name our gateway. Let's just name it Demo Internet Gateway and just create our internet gateway. It is very simple. Now our internet gateway is created. This is our internet gateway ID, but the state is detached. Now you can go attach your VPC to your internet gateway. Just click on attach to a VPC over here and just select a VPC from here. Here is our VPC, so we'll just select it. And now attach internet gateway. So here, the state is attached. Now let us move on to the next step and create a route table. Now as I mentioned before, route table determines where the network traffic from a VPC is directed. Now these are some of the default route tables, but we'll create a new route table. So now we have to name a route table. Let us name it Demo Route Table. And we have to attach a VPC to it. Here is a VPC. Let us create it. We'll get a message saying a following route table was created, and here is the route table ID. We close it. So after we create a route table, we have to associate a subnet to it. So we'll just click on route table over here. Go to subnet association, edit subnet association. Now select a subnet. So this is a subnet, demo subnet. So we'll save it over here. After the subnet association, we have to edit the route to access the internet gateway. So we click on route, edit our routes. Now let us add another route. So the destination will give 0.0.00. Now this means your traffic can flow anywhere. The target will keep it as internet gateway. So we're trying to access our internet gateway. So we'll select this and then save the route. Now we get a message saying route successfully edited. We close it. Now with this, we have created a VPC, a subnet, a route table, and an internet gateway. Now let us see if we can launch an instance in our VPC. Well, let me go to new tab, AWS Management Console. Let me type EC2 over here. I'll go to instances. I'll go to launch instances. Here, let me launch in window instance. So I'll select window. Now I'll select this instance and then go to configure instance. Now here under network, I'll remove the default VPC network and set my network. I'll change the subnet also. And we also have to change the auto assign public IP to enable. We will enable this to create a public IP. So after this, we'll make no changes. Go to review and launch. Before that, let us create a security group. Let us just name it Demo Security Group. And now review and launch. We'll use an existing key pair and now launch our instance. Now let us click on View Instance. Now this might take a couple of minutes. While our instance is getting created, let us go back to a VPC. We go to VPC dashboard, and here you can see there are two VPC. One is a default VPC and the other one which we have created. And there are 4 subnets. 3 are defaults and 1 which we have created. There are 2 default route table and 1 which we created. There was 1 internet gateway which was default, and then we created another one. Now let us check our EC2 instance. We'll refresh it. Now you can see 2-on-2 status check is passed. So we'll click on our instance ID. Now this is our instance ID. This is a public IPv4 address, a public IPv4 address. Now when we come down and see the VPC ID over here, you can see the instance was created in our VPC ID. That is the name of our VPC, and it is also created in our subnet, which is the demo subnet. And you can also see it was set up in the availability zone you had mentioned. Now the instance can be used only by me or the people I permit. A part of AWS Virtual Cloud was given to me to run my resources. And with this, we have come to the end of this video. I hope it was helpful. Happy learning.